With a lot of the traditional end-of-pipe type facilities that we've seen in older types of stormwater management approaches, what we see at these end-of-pipe facilities is deterioration in some water aspects related to water quality. For example, when the stormwater enters into these large stormwater management ponds, it's held there for some time before it's slowly released to the receiving water bodies. Now, the intention behind that is to provide flood control. We don't want all of the stormwater whooshing off of roads and parking lots and rooftops and getting all to the river at the same time and causing riverine flooding or flooding downstream areas. So from that perspective, controlling those peak flows is a good thing. However, a consequence of that is that stormwater is held there for some period of time, and in the summer months particularly, it starts to soak up the sunlight and it starts to warm up that water. And we have monitoring data that suggests that from the inlet of a stormwater pond to the outlet of a stormwater pond, that water can actually warm up by as much as about 5 degrees Celsius. Now, that's a big challenge for us because water's ability to hold oxygen is inversely related to its temperature. So the warmer the stormwater gets as it moves through the pond, the less oxygen it's capable of holding. Now, that's a big problem for a lot of fish and invertebrates that live in those receiving streams, and hence it's a problem for the ecosystems we're trying to protect. We've also seen evidence of nutrient enrichment of the stormwater as it moves through stormwater ponds, because those water bodies tend to be magnets for things like geese. And one adult goose can produce approximately 2 kilograms of solid waste per day. So that adds up to a significant nutrient input to these stormwater ponds as well. One more consequence of these two things, it's sort of a double whammy, is that the warming water loses its ability to hold oxygen. Bacterial oxidation or degradation of that fecal material depletes what oxygen is left, and as a result we end up with these anoxic waters, which create what's known as a chemical reducing condition. So what that can lead to is the resuspension of heavy metals and other compounds that are trapped in those bottom sediments of the stormwater pond, and can actually promote their resuspension back into the water column. These are some of the issues associated with that traditional end of pipe approach to controlling stormwater. In some of the smaller urbanizing sub-watersheds within CVC's jurisdiction, we've been monitoring flows within rivers continually for the past several years. And in areas where we've seen development happening, where more and more subdivisions or greenfield developments are being constructed and more stormwater ponds are coming online, we're still seeing that the peak outflows after a storm events from these ponds are being stacked on top of each other. Now, that's created something called a coincidental peak occurrence, which means that although an individual pond might be doing a perfectly good job at controlling the peak flows or the flood flows coming from a certain development area that it's serving, when you start to stack multiple pond outflows on top of one another inside of the river channel, we still end up with these elevated flows that last for long periods of time, which can have an adverse impact on stream erosion rates.